You know that sound, that sizzle when spices hit hot oil? It's pretty much the signature sound of an Indian kitchen. But have you ever stopped to think about what's actually happening in that pan? It's not just cooking, it's a full-blown chemical reaction. And today, we're going to pull back the curtain and look at the molecular secrets that make it all so incredibly powerful. So let's dive in. So, here's the game plan. We'll start with that sizzle itself, then we'll decode the magic of turmeric and the clever trickery of chili. We'll see how cumin completely transforms its aroma, uncover a mind-blowing 2,000% power-up, yeah, you heard that right, and we'll wrap it up by turning your spice rack into your very own chemical toolkit. Okay, first things first, the Tadka. It's the foundation for so many Indian dishes. But why do we do it? Why not just toss the spices into water? Well, the answer isn't just because that's how it's done. It's pure, beautiful chemistry. So tempering isn't just about frying spices to make them taste good. I mean, it does that, for sure. But heating them in a fat, like oil or ghee, is a very deliberate, very crucial chemical step. It's how we unlock their full potential, not just for our taste buds, but for our bodies, too. And right here, this is the master key to everything. See, many of the most important molecules in our spices, think curcumin in turmeric or capsaicin in chili, are what chemists call lipophilic. It's just a fancy way of saying they love fat and hate water. They dissolve perfectly in oil, but barely at all in water. So that oil is the perfect chemical taxi, pulling all those amazing compounds out of the spice and delivering them right into your food. Now, let's see this whole idea in action with our first hero ingredient. Turmeric isn't just a spice that makes things yellow. Oh no, it's a chemical powerhouse. So let me introduce you to curcumin. This is the molecule we've been talking about. It's the star of the show, it's what gives turmeric that incredible color, and more importantly, it's the source of almost all of its amazing health benefits. And the science on this is absolutely solid. Curcumin is a rock star. We're talking anti-inflammatory, antioxidant. There's even compelling research on its anti-carcinogenic properties. This isn't just some folk remedy passed down through generations. It's a legitimate medicinal compound that you have sitting right in your kitchen cabinet. Okay, quick question. I bet you've seen this happen. You get a little bit of that bright yellow turmeric stain on your shirt or a kitchen towel. You take it to the sink, add a little soap, and poof, it's not yellow anymore, is it? It's red. So what on earth is going on there? Well, this is one of curcumin's coolest party tricks. It turns out it's a natural pH indicator. In a neutral or acidic setting, it stays yellow. But the moment you introduce something alkaline, like soap, its molecular structure literally rearranges itself. The atoms shift around, and that changes the way it reflects light, making it look brilliant red. It's a chemistry experiment you can do in your laundry room. All right, so from a chemical that changes color, let's move on to a chemical that plays tricks on your mind. Let's get into the science of spicy. You know that burning feeling you get from a chili? Well, here's the secret. There's no actual heat. Your mouth isn't getting hotter. It's a clever chemical illusion, all thanks to a molecule called capsaicin. What it does is bind to the specific pain receptors in your mouth that are designed to detect real heat, and it tricks your brain into thinking you've just touched a hot stove. It's a total con artist of a molecule. And we can actually measure this trickery. Using something called the Scoville Heat Unit Scale, or SHU, a pretty standard jalapeno pepper lands somewhere between 2,500 and 5,000 units. That's a nice little kick, right? But believe me, we are just getting warmed up. Now check this out. The Nagarhari chili from Assam in India registers a blistering 855,000 Scoville heat units. That's the difference between a little campfire and a full-on inferno, and it all comes down to the concentration of that one molecule. So really, this scale is like a chemical ruler for spiciness. It takes us all the way from a bell pepper, which is basically at 0, all the way up to the absolute limit, pure crystalline capsaicin. And that clocks in at a mind-numbing 16 million SHU. Don't try that at home. Okay, we've talked taste, we've talked sensation. Let's move on to the science of smell. What's really happening on a molecular level when you toast a spice like cumin? So first, let's meet the molecule responsible for that distinct, earthy smell of raw cumin. It's a compound called Cuminaldehyde. That's cumin's signature scent. But we can actually make it even better. So when you dry roast cumin seeds in a pan, you're not just warming them up, you are performing a chemical intervention. You're kicking off the famous Maillard reaction. This is the exact same reaction that makes toasted bread and seared steak so delicious. It breaks down amino acids and sugars and creates brand new flavor compounds, transforming cumin's raw scent into that deep, complex, nutty aroma that we all love. All right, get ready for this, because this might be the single most powerful example of chemical teamwork in your entire kitchen. This is where things get really, really cool. Okay, so we've established that curcumin is amazing for us, but there's a problem. Our bodies aren't actually very good at absorbing it on their own. Most of it just passes right through us. So how do we fix that? How do we amplify its power? And here's where the magic of synergy comes in. The answer is incredibly simple. You just add a little bit of black pepper. The piperine in the pepper, when you have it at the same time as the curcumin in turmeric, increases the bioavailability of that curcumin by a jaw-dropping 2,000%. And no, that is not a typo. 2,000%. So how does this even work? It's actually brilliant. The piperine from the black pepper acts like a bodyguard for the curcumin. It runs interference, blocking the specific enzymes in our liver that would normally break down the curcumin way too fast. This gives our body way more time to absorb all of its benefits. It's the perfect chemical partnership. Okay, so we've unlocked all these amazing molecules. We've learned how to make them work together. So how do we protect them once they're in our kitchen? How do we keep them potent? You gotta know your enemies: heat, light, air, and moisture. Each one of these is like kryptonite for your spices. They degrade all those wonderful volatile compounds that give spices their flavor, their aroma, and their health benefits. This is why keeping your spices in an airtight, dark container isn't just about being tidy. It's a chemical necessity to protect your investment. So the next time you open up your spice box, your masala dabba, I want you to remember that you're not just looking at a collection of seasonings. You're holding a sophisticated, powerful chemical toolkit. Every single pinch you add is a calculated decision, a beautiful balancing act of flavor, aroma, and nutrition. It's a masterpiece of organic chemistry, hiding in plain sight, right there in your kitchen.